got our stack.h class coded. Now we're going to code all of the methods in our stack. And some of these are going to be pretty easy, and some of these are going to be a little bit more difficult. Let's do the easy one first. The easy one is the constructor. Constructor, all we're doing is defining our variables, and we only have one. So we're going to just say top equals null pointer, because as soon as we create the stack, it's going to be an empty stack. This one I want to come back to. I want to have a little more information before we do this. So let's go on, see what's next. We've got the destructor. Let's do this push one. Let's add to our stack. So let's go copy that. Y type if we don't have to, right? All right. So I'm going to put in my method, and then I'm going to put in my scope resolution operator, and make this a method. All right, here we go. Going to add to the stack. The very first thing I need to do is create a new node. Let's show you. Let's erase this, do this again, create a new whiteboard. Grab a pen. Oh, I have colors. I didn't know that. All right, I'm doing green. So right now I have a pointer to the top of my stack. My pointer is not pointing anywhere because I have nothing in my item. Now suppose we're going to add the value 6. What we need to do first is create the node. Remember, the node has two parts. It has the data, which will have my 6 in it, and then it will have a pointer to the next node. There's not going to be a next node on the bottom of the stack, so this is just going to be pointing to null pointer. Okay, so that is the situation where we're dealing with if there's nothing in the stack. So that's what we're going to code first. We're going to say, well, first let's get our node. Let's see, I need a pointer to, I'm going to call this to add. This is the node that I am going to add. And this is a new node. There we go. Okay, now I need to populate the data portion of this. Remember, if we go back to our definition, there's my string data, and I'm going to set it equal to the data here. So when we were dealing with structs last time, if we said to add dot data, and then we could set that equal to whatever we wanted, right? Well, in this particular situation, we're going to have to change this. First of all, we don't want to set it to whatever, we want to set it to whatever data they specify. And then second of all, we can't use the dot operator when we're dealing with pointers. We have to use, well, we can if you do the dereferencing operator and you have a bunch of parentheses. I hate that way because it's too confusing for me. I don't know why. I like using the pointer notation because I can remember that a pointer uses pointer notation. See, there's your mnemonic device to remember not to use the dot operator. It's a pointer, so we use pointer notation. So I'm filling up the data portion. The next thing I want to do is I want to determine if there's nothing in my stack. So I'm going to do an if statement, and I'm going to say if top equals null pointer. That means there is nothing in my stack. Empty stack. All right, we'll comment there. If it is, then I want to set the top to my to point to my to add variable. So now top is equaling to add. It's basically saying top is pointing to my node. The next thing I want to do is I want to set, so now I've got top pointing here. I want to set this next value to point to null pointer because as you've noticed, it doesn't by default set to like 0 or anything like that. We have to specify. Now I can do this one of two ways. I could say top arrow next. Next is the portion we want to set. Alternatively, I could say to add. And the reason why is because both of them are the same thing. We specified this. Both pointers, these are both two pointers pointing to the same location in memory. So it doesn't matter if we use top or to add right here, it should still work. Okay, here's the second situation. The second situation is if they don't add to the very first value. What we want to do is create a node. We want to fill the data with whatever node information they're adding. I don't know, 42. I haven't done that in a while. But instead of setting this to null pointer, I want, hey, how come it let me point there? I want to point this to wherever this is right here. All right? Okay, so that's our else. This is anything that is not the first node. Okay, so I'm going to first specify that, here we go, bring this in. I want to set this next value to point to this. This is currently the top of the stack, right? So all I have to do is set my next value to point to the top of the stack, and I will have accomplished what I want. We've already seen how to do that here. We're just going to say to add next equals top. There we go. Okay, I'm not quite done, because now that this node is pointing down here, I want to take my top pointer and point it to the top of the stack up here, right? So I'm basically doing this code again right here. There we go. Top equals to add. All right. Okay, this one is done. Yay, hooray, hooray. We're not doing so bad. Okay, let's do peak. That's a short one. There's peak. Sorry, I've got Gravity Falls in my head. All right. So there is my function prototype. This is going to be one of those cute little fun methods. All I want to do is view the top of the stack, and I want to view the data that's in it. So I'm just going to say return top. Remember, we have to use our pointer notation, and I want to view the data that's in that. That's it. We're done. It's just going to view the top of the stack. Okay, 2 methods down. Let's do our pop function next, and then we'll go back and do our destructor. Pop. I cheated. I went out of order. I did the easy one first. Oh, come on. All right, paste that in, stack. Okay, for this particular one, we only want to remove from our stack if our stack is not empty. Now we can determine that using 2 things. I could say if, remember I have an is empty. I haven't coded it yet, but I've already put the function definition in, so I may as well use it. We could code that one next, so it'll make you feel less stressful. So that's an easy way of doing it. You can use methods that we've already created in here. So if my stack is not empty, then I'm going to delete the top value in the stack. And it's not too bad. What we have to do is we need, okay, let's show you. Bring this back. Our problem is, what we want to do to delete the stack is we want to take this pointer and get rid of it, and we want to point it down 1, right? That's what we want. The problem is as soon as we've done that, then we can't delete this node because we have nothing pointing to it. So what we're going to do instead is we're going to create a pointer called maybe temp, and we're going to point temp to wherever our top is pointing. Now that we have a temporary pointer pointing there, we can take this pointer and point 1 down where we want it to be, because this is going to be the top if we delete that one. And then we can delete temp, and then this will be the new top. All right, so that's the order that we have to do that. Let's back up. Love undo, because it's going in history. Going back in time. Okay, first thing we want to do is declare our temp pointer and point it to the top. Okay, here's a new fun keyword that I didn't tell you about. Actually, we'll keep it simple. I'm going to say node star temp equals top. Okay, there is my temp pointer. Next, I want to take my top and I want to point it here. So I basically want to point it wherever this next value is pointing. Why does it keep resizing my shape? I want to point it to wherever next is pointing to is where I want to set top to. So here I'm going to say top equals top arrow next. Whoa, weird. It's kind of like an I equals I plus 1. I'm setting top equal to its own next value. Now that I've got my top pointing to the correct node, it's no longer pointing here, it's pointing here. Now I can delete my temp value. So I'm going to say delete temp. Okay, pop is now done. Okay, let's do our destructor, and then we've already used our is empty. Let's do is empty next, and then we'll do our destructor. And here's our is empty. Grab that. We need like move this up or something. Okay, don't forget your scope resolution operator. Now, is empty is a pretty easy one. All we need to know if the stack is empty is if the top is equal to null pointer. Because if the top is equal to null pointer, our stack is empty. If our top is not equal to null pointer, it's not. I can do that with an if statement. If top equals null pointer, then return true that it's empty, otherwise return false. That's one way of doing it. I wanted to show you a little bit more slick way. I'm going to say return. Now, since I'm returning a Boolean, if I put a Boolean statement here, whatever the result of my Boolean statement is what will get returned. So I'm going to say top equals null pointer. So in this particular situation, if this is a true statement, it's going to return true. If this is a false statement, it's going to return false. Either way, if my stack is empty, it's going to return true. If my stack's not empty, it's going to return false. Okay, now we're on our destructor. That one's already coded in here, so I don't have to copy and paste it. What I have to do here is delete all of the stack, because whenever you use the new operator, you have to use the delete operator, and here we are using the new operator. This one's not too bad though, because I don't even have to deal with pointers on this one. I'm just going to keep going while the stack is not empty. So our exclamation mark means not. We'll review there. So long as my stack is not empty, I'm going to pop the items off the stack. Oh, that's why I had you do the is empty and the pop first before we did this destructor. That's it. It's going to go through, it's going to keep iterating and keep deleting the top value until my stack is empty. This one is now done. We are on the last function, and then we'll put this all together in main and make a fun, I think it's going to be an upchuck program. All right. So last one is my friend function. Remember when we use a friend function, when you declare it, you use the keyword friend. When you put it into your class, you don't use the keyword friend. You just have the OStream. I'm going to call this out. I'm going to call this, I don't know, S for stack. So what I want to do in my OStream operator is I want to iterate through my linked list, basically my stack. So that means I need some sort of temporary pointer. I'm just going to call it current pointer that is going to allow me to display the data at the top of the stack, and it'll allow me to go through the stack to get to to all the values. So I'm going to say node star cur. Now I can't just say equals top. Normally that's the logic I want, but the problem is I'm not in my class. I have access to the class variables, but I have to use it through my parameter s. So I can say s.top. Looks like the word stop. It's going to confuse me. But that's why I have to do this, because this function is not in the class. Now I'm not deleting any pointers, so I can't iterate till my stack is empty. Otherwise, every time I display my stack, it's going to delete everything in there. So instead, I'm going to keep going until my current pointer is equal to null. So long as it's not null, I'm going to keep iterating and displaying values in this list. So the very first thing I want to do is I want to display whatever data is in the current pointer, because that happens to be the top, because we specified that right there. So cur, and I still have to use pointer notation to display the data. And then maybe put some spaces in between each of them. Now to move to the next node in my list, let me bring up my whiteboard again. Let's do a new one. And we're going to have lots of pretend values in there. Ooh, let's do blue this time. So there's a node, there's a node, there's a node, there's a node, and I want to display all of these. So cur currently is pointing to this one right here. Now I want to make it, and I've already displayed this value, whatever it happens to be. Now I want to take my cur and I want to set it to wherever my next value, this next value is pointing here. So I want to set my current to wherever its own next value is. That way it'll take me to this one. So I'm going to say cur equals cur arrow next. And that way it'll take me to the next node in the list. And it will keep doing that until it reaches this last one. And this last one's pointing to null pointer. And since that will not be a true statement, it will fall out of the loop and be done. Okay, I think we've got, did I forget any? I got his empty, Can't remember, did I miss any of the functions? There we go, we did peek. Think we got them all. Okay, catch us in the next video and we'll implement our stack by coding the driver for it.